We can think of a function as an input-output rule. What the function does is for every input value in the function's domain, it assigns exactly one output value. In the functions that you're used to, we're typically going to use x as the input value and y as the output value. Um, it's a common misconception that a function is necessarily a very clean algebraic rule, but that's not always the case. Let me show you what I mean. But up here on the left, some functions that are defined by simple algebraic formulas. For example, f of x equals x squared plus 1, g of x equals sine x, h of x equals the absolute value of x. But it's not necessarily the case that every function has such simple rules. You can see over here, I've defined u of x by a fairly complicated rule. This is a piecewise function that many of you will recognize, and we'll get to that shortly. But as you can see, it has different rules depending on where along the x-axis we are. And v of x has a rule that can't even really be expressed by a simple algebraic formula. It's a rule nevertheless. So just for example, if I were to graph the function u of x here, u of x is a function of x, we can see that if that's 1 and that's 2, this function has, as long as the x value is less than 1, it has a value of 5. And for 1 to 2, it looks like the exponential function, and then after 2, it's going to look like a reciprocal function like that. So that's a function that has a fairly complicated rule. If I graph v of x, what we can see with v of x is that it's a rule that just assigns the value 1 to every even integer and 0 to every other number. So any rule can be a function provided that it assigns only a single y value to a given input x value.